we're looking at Chapter 6, Section 6.4, represent data using polynomial functions to solve problems. There should be exponential functions to solve problems. We're going to determine an exponential function that best approximates the data, and we're going to answer questions based on exponential regression. So in Chapter 5, at the end of Chapter 5, we looked at polynomial regression. In this section, we're going to look at exponential regression. So recall that there were some characteristics of an exponential function that we investigated, that we analyzed, and we seen that there are 0 x-intercepts, that there is a y-intercept and it's A. The end behavior extends from quadrant 2 to quadrant 1. The domain is x belongs to a set of real numbers, and the range is y is greater than 0, or y belongs to a set of reals. We investigated regression in Chapter 5, and a line or a curve of best fit is developed through statistical analysis of the data. So you would have taken this table of values, and you would have entered it in some form of technology, and it would give you a scatter plot. You would also then do, in this case it was linear regression, and it gave you a formula, or it gave you an equation that best approximates the data. We have a line of best fit, which is a straight line that best approximates the trend in a scatter plot. A curve of best fit, the curve that best approximates the trend in a scatter plot. And in these regression questions, we're going to be able to interpolate, which is a process used to estimate a value within the domain of a set of data based on the trend, or extrapolate, which is the process used to estimate a value outside of the domain of a set of data. So we have looked at the 3 types of regression in Chapter 5, a linear regression, a quadratic regression, and a cubic regression. And now, in Chapter 6, we'll look at exponential regression. So if we look at this this example right here, we have an exponential regression. Here's the equation that best defines the data. And we have a curve of best fit. What is the range? And of course, the range would be, as with all exponential functions, y is greater than 0, or y belongs to a set of reals. What is f of 7? And we would say that f of 7 would be, when we replace x with 7, to the power of 7, and we would see that that would give us 373.865. That would be extrapolating. We're going outside the domain here. It says, what is the y-intercept? And we're given the function. And of course, we know the y-intercept of an exponential function is A. And so we have 3.0465. Here we have another example. And once again, it says that the exponential regression function describes the temperature of a coffee cup after a period of time in minutes. This exponential regression, it will be told to us what type of regression it is, so we won't have to look at a graph or an equation and determine what type of regression is happening. It will tell us the type of regression. Is the function increasing or decreasing? And we know, by looking at this function here, that it is a decreasing function. What is the y-intercept? And for the y-intercept, we would look at what it is based on the trend. It's 171.62. That would mean at time 0 that the trend, the curve of best fit, this curve of best fit, would have a y-intercept of 171.462. That means that the temperature of the coffee cup at time 0 will be 171.462 degrees Fahrenheit. It says, what is the temperature of the cup after 51 minutes? And therefore we will replace x with 51. And this will give us 92.634. That's degrees Fahrenheit. So in summary, you'll be expected to answer questions using a graph of a regression function. You will also be expected to substitute values into the regression function to answer questions. Don't forget, you will be given each type of regression, and you will be expected to answer questions on the characteristics. For example, the y-intercept, leading coefficient, domain, range, increasing and decreasing. All these things you'll have to know how to determine from a regression.